a pleasure to be here today. I am now in California and I'm lucky to follow up the presentation on direct air capture so that will make my presentation easier and hopefully faster as well. The technology that distinguishes global thermostat has been identified as a top 10 breakthrough technology in 2019, and since then received several awards that will be listed by the MIT Technology Review, curated by Bill Gates. This is just a picture of me and describing my background as a mathematician with a PhD in mathematics and another one in economics from MIT and UC Berkeley, currently also a professor at Columbia University and chief executive officer at Global Thermostat. And for this purpose, one important piece of background is that I designed and I wrote into the Kyoto Protocol the carbon market that became the European Union emission trading system by international law in 2005. I want to start from critical 2018 global reports that add to the previous presentation, which I thought was very good from Climeworks. And this is that there is an imperative to do with both what Climeworks and Global Thermostat are doing. It is not possible at this stage to have an impact to stop the most catastrophic effects of climate change without removing hundreds of, if not thousands of tons, in fact, gigatons, which are billions, in a few decades from the atmosphere. So what we're doing is not a nice to have, but is absolutely necessary. And that, I hope, will explain why we are here talking about this now. The reports are in links of the presentation that you will receive, so you can directly print them and read them. And one of them is from the National Academy of Sciences in the United States. Another one is from the Intergovernmental Panel of Climate Change, which is the global scientific authority on climate change. And what they are saying, that direct air capture of CO2 that we are talking about here, you're listening here, is the only option now to avoid the most catastrophic effects of climate change. So there is a very good reason to listen to what we're trying to do and for us to be doing it. Our company started 10 years ago, and we have already removed and have facilities, 3, that remove hundreds, and some of them that are in this moment in construction with Siemens and other companies for 2,000 tons of CO2. And the solution is, as you have heard, is requiring to stabilize on Earth the CO2 that we remove from the atmosphere, but to do it so that it can not just provide a solution to climate change by cleaning up the atmosphere, which seems an extraordinary thing to try to do, and it is, but in addition, to present an economic solution, which is what we have proven within the United Nations is the way to achieve agreement among the nations, the 195 nations, and get the solution implemented. We work very strongly on that basis. This slide simply tells you the imperative, what has to be removed. To stay within 2 degrees, you can see that the removal required by 2100, 670 billion tons, is an average per year of 8 to 10 billion tons that have to be removed. And you can see the science, which is now clear, to prevent global warming above 2 degrees Celsius. Billions of tons of CO2 are already in the atmosphere, and that quantity must be drastically reduced. Not just reduce ongoing emissions, which is critical, but in addition, the legacy CO2, which is already there. We need urgently a cost-effective, scalable solution to directly remove CO2 from the atmosphere. And this is what all the scientific bodies and the international organizations are saying must be done. And do what with that? This slide tries to give you an impression of what is the current 1.1 trillion annual CO2 market, which is reported by McKinsey for this decade. Food and beverages, concrete, aggregates, which are a combination of concrete and stone, polymers, renewable plastics, methanol, with which you can make fuels, other industries, and very important, water desalination. You will say, okay, and how much does the market pay for the CO2 that you remove? And then, of course, you're going to ask how much does it cost to remove it. But the market prices vary very widely, between $100 in Texas, in the Permian Basin, to $1,500 per ton globally in island states. So, for example, so what this implies is that there is a lot of flexibility about the cost that would make the whole process commercial, and it does right now. The flexibility is because the market price goes between 100 and 1,500 per ton of CO2 sold globally. It's a gas that is sold commercially. This tries to explain the direct air capture solution, and our patented technology is capable of delivering low-cost direct air capture of CO2. And the explanation is in the slide. I don't think for this audience it would make a lot of sense, but I would be very pleased, in any case, you can imagine, to explain how it works. Our previous speaker was kind enough to give a description. The systems are different in considerably important ways, particularly in cost, and the asymptotic cost that can be achieved through learning by doing, which is critical in technology and technology innovation. But the general process is the same. You move a lot of air over material that has a preferential affinity for CO2. It captures the CO2, then you separate it and you obtain a 80 or 90% pure gas at atmospheric pressure. And that is what can be compressed, liquefied if necessary, and sold. That's the important thing, is that being direct air capture, removing it directly from air, and considering that air has the same concentration of CO2 all over the world. It distributes uniformly. It means that you can save an enormity in the cost of transportation. CO2 doesn't like to be transported like electricity doesn't. And as a result of that, it's very important to save on transportation. And direct air capture allows you to take the CO2 wherever in the atmosphere, directly from air, because the concentration is the same right now in Moscow, in Buenos Aires, and in New York, and in California, where I am speaking.
Graciela, I'm sorry, the 10 minutes are already over, so I would like to ask you to come to an end and conclusion. Thank you very much.
Absolutely. This explains the cost decreasing over time. This explains a law that we created, bipartisan 45Q tax credit proposal that became a law in the United States, and our most important current project. This project, there are two. One of them is with ExxonMobil to scale up our technology to a gigaton scale. And the second is a contract with Siemens, and it includes also ExxonMobil, and HIF and AME as investors, that includes Porsche as a user, to provide CO2 to produce synthetic gasoline anywhere in the world. There is also a DOE, Department of Energy project with Black & Veatch to design, already awarded, to design 100,000 tons per year of CO2 direct air capture plant. And that gives you some idea with the logos of the firms we're working with. The next step is scaling up. You have here some drawings of our facilities in Silicon Valley and in Denver, Colorado. These are our significant developments and most important milestones. This is a picture of some of the members of the team and a disclaimer. And this, most important, is a thank you for listening, and just let me know if there is anything that I can provide. We are very interested in investment, of course, like any company in our position would be, and look forward to talking with you and to giving you all the information you may require.